Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hi everyone, thank you for coming today for our presentation on wearable technologies and soft sensors. I am thrilled to be presenting to you Akseli Reijo. He is the CEO of Clothing Plus, a Finnish company. His company has been researching and developing soft sensor technologies for the last 15 years. So today he's going to present to you some of the work that they've been doing. So I'll give you Akseli.
Thank you. Yeah, my name is Akseli Reijo, and I'm very happy to see that so many of you are here to listen to this story, what I have in my mind. So, first, a big picture how we see the market. It was about 10 years ago when we last time saw increasing activity around the wearables. There was a companies called Philips, Levi's, France Telecom, and many others kind of excited about this opportunity. But on that time, 10 years ago, actually the bubble exploded and the business almost vanished. Now we are seeing the same thing, increasing activity, lots of news, lots of press releases, even product launches are happening. And we are happy to see that the majority of the concepts that are behind the launches and the presentations are more user-orientated, are more based on the real needs and the real behavior. And even on top of that, I'm happy to see that the technology that is behind the launches are far more mature than it was 10 years ago. I would say that 10 years ago, everything that was launched was completely unable to fit on the washing machine, for example. At the moment, when we see the launch, when we see the activities, everything is washable. And many other logistical things, price-sensitive things, has been built from the different approaches. So we believe that we are absolutely happy that the activity in this space is increasing, but we are somehow very confident that this time this will fly. Briefly, how we see the market. First of all, we see the e-textile applications. There is a thermal things. There can be a therapy or treatment. There can be actually the heating and cooling functions. There can be a feedback functions. A lighting illumination is another application area. It can be an indicator. It can be a visual feedback. It can be the communication. What do you want to say by your clothing? It can be made with the illumination effects. Then there's a haptic world, where the different kind of user interfaces are built on top of the e-textile and wearable thinking. There can be switches, there can be game controllers, there can be a massage therapy things. And then the fourth main application area, it's the sensors. So there is lots of application areas where the sensors can be used, but the bottom line is that you do the sensing through the wearable and textile-like materials. How is the market? So where these applications are used, there is clearly a safety and professional market out there which is using these applications. There is a fitness and wellness. There is this infotainment market and health and medical market. And actually where the Clothing Plus sees the most of the fruitful and meaningful applications or launches happening at the moment, they have something to do with the sensors, and they fit on these two markets. Of course, we are looking the other opportunities as well, but we as a Clothing Plus, still small company, we have to be very careful to follow the real market behavior and commercial activities. So these green boxes highlights the area where Clothing Plus is very active. So our vision is to make comfortable wearable electronics. And we feel that by approaching this vision through the textiles, we have an extremely nice material in hands, because textile is very comfortable material. So if we are able to integrate the sensors, for example, into the textile material, we are almost in field of comfortability immediately. So we see that by approaching this with textiles, we are there. And when we are focusing on sensing, we feel that all the wearables, all clothing related, all accessories related things kind of offers very natural platform for doing sensing. And especially when we think about, for example, the clothes, the textile material based clothes, we immediately understand that we get a pretty fruitful information base to integrate the sensors, since we are in touch with the textiles. No matter are we sleeping, running, working, we are in touch with the textiles over the very large area. And there is even textiles, there is even pieces of clothing and pieces of accessories that are in very tight connection with the user. For example, the bra or the underpants, they already have an interface to touch the body very naturally. And we have accepted those pieces to be worn over the days. So we feel that textile and clothing approach gives us a very good tool to realize that vision and keep that focus viable. This is something that I say that presents our academic slide. So I'm not going to give you any more detailed education, but these are the main findings, what we have found out, the basic strengths of textile integrated wearable sensors. So first of all, as I said last time in the last slide, it's very natural to put on and comfortable to wear. I would even say that it's the most natural thing to put on is the clothes. In some cases, also the correct sensor placement is viable. So to get the sensors on the right positions without anybody helping you, it somehow comes into the picture through clothing. For example, we did a sensor vest. I come back to this later, but we did a sensor vest with Philips, and their requirement was that they need to get sensors placed in tolerance of 1 centimeter every time that they put the sensors on. Typically that needs almost a medical kind of, some kind of the medical professional to help you to glue or place the sensors with that tolerance. But we were able to design a garment, a vest, that repeatability places the sensors on the tolerance of 1 centimeter. So it gets the repeatability, but it also gets the one-time reliable sensor connection and sensor placement. We also see that the required cables between the sensors and electronics, those can be hidden into the textile form factor. Since textiles, for example, the vest, underwears, whatever, they already have the large area going around the body. Why not to integrate the wires into the same platform and get them vanish? Because if there would be any kind of wire hassle, hanging wires, whatever, that will both destroy the measurements, because it can make the movement or behavior different, but it also can destroy the signals, since when you are when you're feeling that somebody's seeing that you are doing a measurements, and you can get mentally loaded from that position, that the sensing is somehow visible. By hiding the sensors into the textiles, you can get the sensors vanish, and you can live as you want. So we believe that by integrating the sensors into the textiles, we can do very long-term sensing without loading anybody into this environment at all mentally. Then some kind of concrete things. What have we done in this business? Are we only talking, or have we already done something? Luckily, we have done something. As I said, that the business kind of potential or the big vision of wearables, it collapsed about 10 years ago. Luckily, we survived. We walked to Polar, who was the giant on that time in the heart rate sensing, and we told them that we could transfer, we could further develop the plastic cold heart rate sensor strap to become comfortable, textile-like, easy to put on. And they understood it immediately. They said that actually one of the biggest obstacles on selling the heart rate systems was the hard plastic cold piece of electronics that you had to wear. And this was actually the product that helped us to survive, to stay in business, but also start learning and start understanding what is really the business behind the wearable sensors. But this was an example which we launched with Polar more than 10 years ago, and of course we were thrilled to be able to work with a company like Polar, but also we were thrilled to be able to be on the market with the real product. And we were following very closely that will this be a sustainable, long-term, meaningful trend in the product evolution, or will this be only a short-term a fashion thing, something for the marketing guys to get benefit out of, and then they would kind of back to the plastic straps. But no, they didn't back up. The consumer feedback was so overwhelming that consumers insisted to have more textile straps. So that turned out that textiles can be used as a signal or sensors, signal connectors, signal wiring methods in a demanding sensor environment. So there's lots of distortions, lots of movement artifacts, lots of moisture, lots of problems in this area. So if we are able to do a textile sensors that meets high quality requirements that comes from the Polar, we felt that this is really a doable thing. And actually, their competitors felt the same way. The other companies, they naturally gave us a ring after a couple of years that can they have the same thing. And now we are supplying millions of straps. So at the moment we are on top of the others. We are supplying to Suunto, Garmin, Adidas, Timex. All these companies are buying the straps from Clothing Plus. Of course, we have further developed, pushed, designed the straps. It's not anymore the same that you saw 10 years ago, but the idea is the same, but the design and performance is even better. So this is something that has happened. This is something that is really commercially existing. It's machine washable, it's durable, it's everything that is requested from the demanding electronics industry. Very logical thing to ask after having the textile strap, especially from the females, is why don't you integrate the strap and the bra together? Because majority of the users, the female users, they have the problem on wearing the bra and the strap at the same time because they are overlapping the same part of the body. And since the bra is already needed there from the physical reasons, it's difficult to say that try to use the strap on the same place because it's almost impossible. So the people they kept asking that, why don't you integrate these two worlds together? And this obvious question has kind of gave us a guts and feeling to start integrating these two things. This is actually the vision that we had already more than 10 years ago, but we were not able to do that vision or implement that vision commercially because there were no removable transmitters. So we had to do the straps first with the detachable transmitter to be able to jump into this business. And at the moment, we feel that we are in front of the huge opportunities. And at the moment, we are supplying the sensors to Danish company Pure Lime. We are shipping to Lululemon. We're shipping to Adidas, and we're shipping to Under Armour. Did I forget something? Doesn't matter. But still, there is a big underwear company, sports underwear companies, who has understood that this integration is meaningful. This integration makes the usability, makes the heart rate sensing even more comfortable for the users. You don't need to wear anything extra. Just put the sports clothes on and you will be monitored. And from the business-wise, this is naturally much bigger opportunity than the strap business. Because we believe that especially on the women's clothing business, we believe that after 5 years, almost every high-end sports underwear should include the sensors. Already today, the difference, for example, the price difference. If you buy the Pure Lime or Lululemon bra with sensors or without sensors, the price difference in shop is only €5. So the price difference is almost meaningless thing. And even if we get further down to this business, it will be smaller. I have some samples with me. Probably we make it so that I show you something here. But if after the presentation you feel that you want to get your hands on to these, please come and look. So this is the bra with the place for the transmitter and the integrated sensors. You must wet the sensors. It's not required for everybody, but majority of the people needs to get a good sensor skin contact through the water. This is a shirt that we have created and what we are manufacturing to Adidas. This is a shirt especially for the soccer players. And the unique in this shirt is that typically the transmitter is located in between the sensors. But because the soccer, the chest is the control area for the ball, you can't have the transmitter here. And that's the reason why we have wired or still placed the sensors here on the fruitful areas where you have the strong signal. But instead of having transmitter here, we have built the wiring system to put the transmitter on the back. So actually I can turn this around to show you how the wiring is built up. So there are sensors, and then there's a wiring system, and there is a pocket for the transmitter.
Sally, would you like to pass it around?
Yeah, that's a good idea. Yeah.
So why don't you, is there a reason you're not putting sensors at the back itself, closer to the transmitter, so you get rid of the wiring?
Yeah. In some applications it would be possible, but especially within top athletes, with the lots of movement artifacts, lots of other distortions, we must sense from the area where the signal is strongest. And since we have a maps, a kind of academic maps, where the signal is strongest, and it's around the chest. Of course, there is a place to do it from the back as well, but we would lose a bit of the reliable signal. But that's a good question. If we go more low intensive training sessions, the heart rate can be read from very many different places, from the shoulders or as well from the hip. Yeah.
How severe are these movement artifacts? Because I would imagine for soccer players, especially if you're hitting the ball, if they're running around,
yeah,
you're not going to have contact most of the time.
Actually, that's not the loose shirt. That's quite tight, well-fitting shirt. But of course, you still lose the signal sometimes when there comes a real collision or somebody is pushing you. You will lose the signal. And
Have they tested it? Have they used it?
yeah, this is widely used in the MSL and in the European top leagues.
I noticed when you go around a curve, you actually flip.
Yeah.
Is there a reason you can't just weave in a curve?
Those are mostly the production effectiveness questions and as well the insulation questions. So there's a lots of different kind of requirements for the signal wiring, and we got the best combination between the costs and the manufacturability and the signal quality by doing it like that.
But if you could do anything, I mean, if cost was an issue, you could.
Yeah, then we can do whatever. yeah. Absolutely, there's a lots of options. There has happened lots of cost optimization in that. Yeah.
Are you selling the actual monitor as well? And what happens if you don't remove it from the piece of clothing and you wash it?
Yeah, that's a good question. There is completely possibility to do it fully integrated. It needs a bit more expensive battery, because the typical coin cell battery, it will explode in the washing machine. The temperature load is too high. So, but it's easy to select a bit higher temperature range battery and integrate that in. So we have a good understanding how to integrate it permanently, and I personally believe on that. There is not going to be any more removable things after a couple of years. At the moment, there are still removable things. And the other question, that do we sell also the module? We have couple of partners with whom we have kind of developed and validated that the combination works perfectly. And at the moment, actually, I'm happy that you asked, is that we are selling the absolutely the smallest transmitter on the market, and in the same package there is also the most minimalistic connector interface or connector. This is not so valid on the straps, but we are very happy that we were able to remove the snaps from the bra, because it didn't look so good. But I'll come back to this later. But I believe on integration. After a couple of years, you can't remove the transmitter. So this is one trend, one business that shows the value of integrating clothing and sensors together. Yeah.
Can you comment on the battery life and now and in the future, and whether it's going to be possible to wear this and record the entire day rather than just an hour running?
Absolutely, yes. Actually, one of the most power-consuming things is transmitting. So if you would be just recording it, the power consumption level goes dramatically down. So I don't see any major problem on that. It can be thousands of hours that you can record the data with that.
On one battery.
Yeah.
And then the battery can be recharged.
Or replaced.
Like $10 on batteries every day.
Sorry?
You don't have to spend money on batteries every day.
No, every day. No. One battery per year, like.
Already on the market, or it's just going to happen in the next couple of years?
How would I say? If I recall it right, this transmission technology, it covers like 1,000 hours. I'm not exactly sure. Was it 1,000 hours roughly? Maximum. Yeah. But if you would remove the transmission from here, it's completely off-the-shelf stuff. Kind of switch off the transmitter by software. And because somehow we are proud that we are able to do this business on quite demanding environment, both from the cost-wise, design-wise, and the signal quality-wise. So all this sweat, all this movement, all these designers' requirements and the cost requirements, we have solved the problems. So actually we believe that it's quite easy to move away and move further in this business and integrate the sensors in other applications as well. I have another example, the vest that I already referred. We made a vest with Philips. So Philips is one of the companies who believes on home health care. They believe that the chronic diseases, chronic problems that people have, they should be treated at the home. The hospitalization, the hospital environment, it's good for the acute problems, but not good for the chronic things. And actually, the Philips identified a problem that is the heart decompensation. So the huge amount of people have the weak heart. That's very well known. And when the heart gets too weak, it happens. I couldn't say that my heart is getting weaker. It happens kind of without an alarm. And when the heart gets too weak, it starts to accumulate the water in the lungs. And the Philips said that if you are able to measure amount of the water in the lungs, and especially if you are able to do the trend analysis, draw the trend line, how the water accumulation is going or accumulating there, it could be the way to give an estimation or indication for the both user itself or the patient itself or the doctors to start dehydration medication and some other treatments to avoid the hospitalization and the critical care. And that was a challenge. That was a great challenge. Could you please design a vest or the piece of clothing that is easy to put on, easy to do sensing, and easy to kind of maintain? And we developed a vest with Philips that measures through bioimpedance the water accumulated into the lungs. And the idea is that the patient, he or her, they put the vest on every morning for 5 minutes. They can drink coffee, read paper, watch TV, something not very active but still live normally. And the vest measures during these 5 minutes the water level in the lungs. And it's not only one kind of one-time measurement. The idea is to do it every morning. So you are able to do the trend line analysis. And actually we are very happy that this vest, it just passed the clinical studies in Europe. So there was 1,000 people from males, females, fat, thin, whatever different things were there. And 1,000 people, they were all using the vest for 1 year. And it was easily shown that the vest really detected when the water starts to accumulate into the lungs, even 10 days before the hospitalization started. So 10 days is a good time frame to start reacting and start giving the right medication and other treatments. So we are very happy to see that we are able to bring this technology, this wearable, easily accepted, effective sensing approach also to the space of home healthcare. And we are very proud to work with the companies like Philips, since they are good in their business and they are very demanding against us. It has been also, yes please.
Can you talk about the electrodes that you had in that vest? I mean, did they require water before you used them and so
Yeah,
forth?
they still require the water. Just to be sure, you can take the vest. Yeah. Yeah, that's and we believe further into the home health care. We believe that the sensors in the home will help users to to get many benefits out of the continuous long-term sensing.
So who owns this? The hospital owns this?
Actually, Philips takes care of that. We just design the vest and sell the vests to Philips. They have the deals with the insurance companies, and so we are not working directly with the hospitals.
So the subjects you used in the study were reported as pre-hypertensive or hypertensive. Did they have any sort of heart condition, or was this just randomly picked people out of?
Those were the team or the group that was chosen to be the validation group. They all had one heart attack in their history, so they were clearly a target group. So there was a big prediction that something bad will happen. So one interesting learning was, of course, from this project, since Philips, they have to be very honest what they do, they have to choose the right way of working. It was also interesting to work with them and understand that why did they choose a wearable textile-like approach, since they had a palette of glued electrodes, plastic things, even implants to do that. But it was so nice to learn and work with them and get a confirmation that there are things that are very kind of valid to do through the wearable textile sensing. So in the very big picture, we believe that actually textiles and sensors gives an extremely nice platform for motivation, show the effectiveness of the medication, give a people a reason to believe on or get some evidences on the if they change their lifestyle. It's a quite rewarding to learn something that when you switch something, it really affects on some parameters in your body. For example, one example that I just learned that I'm not sure do I know the English words, but the one of the most dangerous fat types is actually the fat around some inner parts of your body. And it's interesting to learn that when you start to do any kind of sport, any kind of activity, that will be the first fat to be burned. And it would be so important to tell people that the 2 or 3 times when you did a sport really had a critical effect on the body. Without any sensors, it's quite problematic to see the real change. For example, by just measuring the weight, it comes too slow. With this kind of clever sensing methods, it could be possible to give the feedback even faster. So we believe that different kind of wearable sensors will be there, and we hope to be in a major role while this trend happens. What we promise in Clothing Plus is that we can integrate almost whatever sensor into the textiles. So we are not stuck with heart rate or bioimpedance, not at all. We would like to see from our customers, our business-to-business customers, that they have a need. They have a need to sense reliably from the body something. And then we walk in and we do it. We design the clothes, we integrate the sensors, we do the needed wirings, we need the different needed connections, and we make it happen. And here is a list of some sensors that we have been integrating. And that should be a reference or proof of concept that we can integrate almost anything into the textiles. Yeah?
I assume the answer is no, but is there any way to sense pain?
Yeah.
And localized, so that you know where someone's feeling pain?
I'm not sure of that, but you can see pain easily from the heart rate variability. When you get, there's a great academic study that when people are in dentist, what happens for their heart rate? when they get hurt. It's not getting up. It starts to tick like a clock. So there is no variability. But how to localize it, I'm not sure about that yet. But we could, for example, we could integrate the microphones into clothes. We can integrate the temperature. Microphone, I love the idea to listen the sounds from the joints to be able to do some kind of conclusions that how are you doing? We can sense the temperatures, bending, stretching. We have been integrating optical sensors into the clothes, accelerometers. Yeah.
What information do you get around bending and stretching?
It's hard to define clearly because you can do the predictions of how straight you are standing, or how the arms are moving, or almost
Lack of
flexibility could be one thing to be measured, and probably the combination bending and stretching and accelerometers to get the postures on the ground and stuff like that. But actually, typically the best possible case is that consumer or the business to business customer walks into Clothing Plus saying that our customer base needs to know this, and to be able to tell them this, we need to sense these things from the body, and then we are the partners who solves that. Yeah.
So currently, what piece of clothing or combination of pieces of clothing would integrate most of this stuff in a way that you can wear it all day?
I would say that all these sensors we can integrate into the textile materials. So it's only a matter of piece of garment. Are you wearing a hat all day? If so, then we can do it the EEG. If you are wearing the pants all day, we can do the heart rate. We can do some optical sensing here.
Have you done it, or how would we go about having something to test with lots of these signals being acquired over a long time?
How would we do it? We would build some amount of prototypes. We have, how would I say, the Clothing Plus, we have the building blocks. We have the methods to do connectors, we have the methods to do wiring, we have the methods to do the sensor integration. So it takes a couple of months for us to build the 10 clothes with the specified or selected sensors. And then we test it. Yeah. But typically we need somebody from business of electronics or for consumer understanding to commonly define how really to do it.
Question.
Yeah.
So with accelerometers and microphones and things like that, are you actually printing those electronics so that they're integrated into the fabric? Are you using conventional MEMS technologies built by semiconductor manufacturers, putting them on a board or a Kapton substrate, and then integrating that Kapton substrate into the fabric itself?
Yeah, good question. We are not business of developing the sensors. So we just want to integrate existing commercially proved, miniaturized, cost-effective sensors into the textiles. So we are not printing or developing the sensors on our own. Only some very rare ones. But typically, we choose with our customer the sensors that they want to have in the clothes, and then we do it. Our platform, our building blocks enables it opens the fruitful platform to integrate almost whatever kind of the sensors.
So are you using Kapton substrate? Are you using a flexible substrate like Kapton, or are you using a more rigid substrate using an FR4 or something like that? It's just simply small.
No, since our vision is to do as comfortable things as possible, we are only working with flexible things. Yeah.
What's your obsolescence curve for washing? I noticed that you've got your pads are the same material as in the runs, just silver iron coated fabric. And the last time I saw that, after 25 washes, you're no longer able to get a reliable contact. What curves are you seeing for obsolescence for the currently shipping garments that we just passed around?
Yeah, the washability is one of the main challenges because it's something new that electronics industry hasn't faced so far. So we actually have to push our material suppliers and push ourselves to do the methods to integrate the system so that it can be washable. And
I can believe that'll survive washing.
Yeah.
But unless there's some sort of update that just looks like the same material.
Yeah.
I wouldn't expect it to function after between 25 and 50 washes. Like, what's your curve look like for obsolescence?
We test always all the way to 100 cycles.
You're getting, what's your usage or your failure roll-off over that? Like, you saying 100% usage at up to 100 cycles?
I have one curve for you. Maybe that's so detailed question that we have to dig into this more careful, because it depends on what signal you are sensing there.
I will bug you about this later, but my main question is, like, when you sell that,
yeah,
you have to say, hey, you can get a year's worth of use out of it. And if I'm running once a week,
yeah,
that's fine. If I'm running every morning, that thing breaks in 6 months. Like, what's your window that you're selling? What's your commercial story?
Well, our story is that, for example, when we work with Adidas, we want to promise from our components more than they are promising to their customers. So what they typically promise is from 40 to 50 washing cycles. That's what they promise to their customers.
Sorry, one more time.
40 to 50 washing cycles. What the big brands promises to their customers. So this was just for the inspiration that we are not stuck with the heart rate. We would like to see whatever ideas to be sensed from the body, and we try to be the experts to do that. Few slides about our company. So on top of which resources we really do this. We have 25 persons in R&D to do the development itself. There's mechanical engineers, there's naturally textile engineers, there's a material sourcing, prototyping. We have our own factory in China. What is unique in this story is that whatever we design, we promise that we can mass produce it. So exactly the same technologies that we have in Finland, where we do the R&D, we have exactly the same technologies in China, where we do millions of these products per year. Here is something about the technologies that we use. We used to think that a sewing would be not good enough for this, but no, it wasn't. We had to kind of reinvent the set of the technologies to be able to do the integration. We have different kind of methods for the connector assembly. We use widely the laser cutting. We have 3 different lamination technologies to put the components and textiles together. We have ultrasonic welding, where we sew the textiles in the different methods. We have the dispensing. We have the methods to do the printed electronics. We have lots of electrical functionality in line in the production site, and as well the machine vision. All this is needed to meet the requirements of the sensor industry. They are not happy with the tolerances of some centimeters. They need to get the exact insulations, waterproof layers, shielding structures, and everything should be in tolerance of some tenths of millimeters. So we had to jump away from the multiplied handwork to mechanized and new production methods. These are not completely new in the world, but we are trying to push them in the form factor of textiles. And as said, this is really mass production already. This is not only some prototypes. We are doing millions of these products, textile integrated sensors. This is something that I always want to tell, that we don't have anything off the shelf. So there is no warehouse where you can buy the Clothing Plus products. We always do it based on customers' needs. So we have a development service. After we have understood what the customer needs, we do it exactly like they want. And then we have the production service. So the link between these 2 stories is that whatever is developed there is seamlessly transferred to a real mass production environment in China. And there we have so much focus on the quality. Some facts about the company itself. So the story has started in 1998. At the moment, last year, our sales was in dollars. It was about $10 million. And 27 persons in R&D, plus some marketing and sales guys. Then, at the end, I throw you 3 technology news. I tell about the building blocks that we have developed to be able to implement the vision. These three things has been developed within last year. The first is actually the invention. Our marketing guy came up with an idea of Centerwire. So the idea is that here we have the pants, the running pants or cycling pants, to measure the EMG activity from the front leg and the back leg, to be able to guide the user to use the body symmetrically. But as well, for example, for the biking, you are able to adjust the height of the saddle to be able to use symmetrically or optimally the front and the back leg muscles. So this
measure things like cadence, pedal angle, left to right, power, things like that, or is it still like I can put a lot of sensors on my pedals?
Yeah.
And it'd be great to pick that up without having to use other kinds of.
The biking is this is something.
Yeah, I realize it's not an easy problem. So
it's not an easy problem, and this comes to the same problem from the different angle, and especially when you are doing running or skiing, when you don't have the mechanical bike where to integrate the sensors, the pants is the quite fruitful place to locate the sensors. But here that's actually pretty much the same technology that you saw on the Adidas shirt. It's even further optimized than what it's here, but the idea is to use the same material as a sensor and as a wire. So we eliminated one connection interface here. There is still one connection interface where the wire is turned out to be a plastic connector, where the module itself is clipped in and the information is sent to the phone. But this is a mass producible way on doing a wiring and sensor structures on the pants. I can put this also to go through. The other technology is actually, again, a fancy name, Tracebase. This is something that we have invested quite a lot during last year. And we have done a technology study and a development to able to do an PCB, printed PCB that has a good water resistant or washing resistant. So actually the purity and the good part of this story is that in this platform we can integrate almost whatever existing sensors or the LEDs or components. So there is a pad where we can put the components on. And the wire structure itself is also washable. So here I show you some graphs of these studies. So here, for example, 85 washing cycles, and the resistance over the 40 centimeters has increased, but it fits on the majority of the concepts where we are aiming. So this is over 85 washing cycles, the resistance change. The other graph that helps to understand this technology a bit better is this is a typical flexible copper PCB. This is a bending test. The typical copper wire, in some point, it just gets broken. But what happens to our Tracebase technology? The variance gets bigger, but it doesn't get broken. And it's still only some ohms where you are living. So it's not a clear line, but so far what we have managed to develop is good enough for the majority of the concepts and the technologies where this is aiming. But the idea is that we are able to do layers with the printed technology and meet the washing requirements. And especially what's great in that we are also able to make it very comfortable. By quick look, you could think that this is a bit ugly to put on. This can't be comfortable. But actually, this is an example how it almost vanishes into the clothing. So here we have this technology integrated in. And here, actually exactly the same technology, but it's also made to be stretchy. So by building the fabric layers and place this in between, you can make this electronics both washable but also stretchable.
So these last two examples are examples of the tracing technology.
Yeah.
They don't have it's not a sensor.
You are right.
It's just the tracer.
Yeah, you're right. And we have the technology to integrate the sensors on the tracer and also the connectors on the tracer.
So there's a future whereby the material itself is just one big tracer. You can start to matricize the body.
Exactly.
So to speak.
Yeah. And then you have we have a specific technologies to integrate those tracers into the textile material to make it comfortable and easy to put on. And actually the third technology news is it has something to do with or lots of to do with the connectors. Some of the underwear companies, they are very allergic on the snaps. They don't see the reason why you have two big bulky metal pieces in the sophisticated, nicely designed bra, and we agree them completely. And that was the reason why we developed a connector called flat snap. So we removed a majority of unnecessary metal from the snap and made it as flat as possible to make it possible to almost disappear into the textile structure. And the shirt, what you have in your hand, there is also the flat snap connector present on the back. So it's almost disappeared.
Where are you staying with snaps?
That's a good question, because we have other options, but the snaps, they have an extremely good mechanical spring structure in it to be able to avoid the movement artifacts. So
you could use like nib magnets under the same material you're using. Like it's a pretty common technique that gives you slightly better stiction. Like that.
What was the technique that you referred to?
Magnets.
Magnets.
Magnets under the same silver-coated material.
Yeah. Magnets is an option. Yeah, but there is also the limitations on the magnets. They are not so stable over the time. You can lose the effect. They are if you get them kind of you can break the magnets, and if you are sensitive with the magnets, some of the people, they don't want to wear the magnets, and they are not so cost effective. That's quite cost effective thing. Those I completely follow you. We can do the magnets. That's a great technology. But so far, none of our customers, we have tried that quite a many times, but none of the concepts, commercial things, has never ended up to be using magnets. But magnets is a great thing. Magnets is absolutely a great thing. Yeah. So the spring structure on the snap has been copied into this flat snap idea. And somehow the story behind the heart rate sensor business shows that the snap is very reliable and functional connector type. Yeah?
Does this technology also potentially allow you to straddle your circuit across several garments and different clothing?
Why not? Yeah. So you just need to have on the other piece of the apparel, you need to have the female side, and on the other side you should have the male side, and then just clip those in. Yeah, that's possible, absolutely.
It's mainly if you want to wear a base piece of sensing and then extend it with more sensing, basically with an extra piece of clothing. So
yeah, that's one option, absolutely. Yeah. So that was just to give you an idea that the connector technology is the third main part where we are working. So I would say that it's the connectors, it's the tracers, and it's the platform for as many sensors as possible where we are focusing. And we feel that if we are able to offer these building blocks, our customers are are quite capable on defining their dreams on top of these technologies. And we really would love to throw you a question that this is what we have done with the others. It would be very exciting to do something with the Microsoft. And actually the question is that what could we do with you?
What would be the difficulty in, say, just changing your sensor technology over to using like BTLE so that it can talk to existing mobile devices and phones that are coming out?
Actually, this transmitter, this is BTLE.
Already?
Yeah.
Do you have an open protocol for talking to them?
Yeah.
Is it, I mean, it's published someplace we can get?
This, to be very precise, this is not made by Clothing Plus. As said, this is made by one of our partners, but they are very open-minded and they just want to make this fly high and see this used as widely as possible. But BTLE is actually one of the main radio technologies where the sports industry is lying. Yeah.
What's the most common software interface that users are using to access the data?
How would I say that? Can you, Heikki, help me with this? Actually, Clothing Plus, we are not so good in software, and that's why we are here. So where we are good, we want to integrate the sensors, and then we need somebody to do the electronics who transfers the signals into some kind of electrical signal that can be sent to the software that can actually build the value for the customer.
So who is building the software generally?
Typically, for example, here software is built by Garmin. Software is built by Suunto. Software is built by Philips. So it's very typically our customer who takes care of that. Yeah.
Can you talk a little bit about batteries? I know that there's been work in stretchable batteries and other sorts of forms of power. Have you guys been doing any work and investigations in batteries?
Yeah. As Clothing Plus, we haven't done that on our own. We try to keep our eyes open and understand where the development is going. And absolutely, I see that when these components are ready enough, we just need to adapt those. And for some of the players, we are discussing and trying to push them to meet the washing requirements. Those are very typically the things that they don't immediately understand, or they are not even willing to go in this business because they see already the value in the stretchability so big. But whenever it comes to washable, stretchable thing, we are very curious to adapt those pieces in our portfolio, since we are the integrator.
Any other questions? Great. Well, thank you everyone for coming. And Exceli will be here for a little while if you guys want to just chat with him for a few more minutes. So thank you very much.